First things first, before we start, make sure that you have this chart filled out. The last video went over each of the pieces of this chart. Make sure you have it filled out because we're going to be using it all chapter, and you should refer back to it as we go through these examples and as I talk about these properties. I'm going to be bringing up the properties from this chart. So go back and look at the last video or pause right now and make sure you get everything filled out. So that being said, now we're going to look at some examples where we use the properties of all these shapes to get different measurements about the quadrilateral. So the first thing we need to do in all these problems is make sure we know what shape we're talking about so that we know what properties are true. And the first thing we notice is that here's these sides being the same and here's these sides being the same. Those are the consecutive sides. They're next to each other as opposed to opposite sides. So since the consecutive sides are the same, that's a kite. That's a kite. So we're going to look back at all the things that are true about a kite. And the main one that we know is true about a kite as far as angle measures go is that the diagonals in a kite are perpendicular. And since I know those diagonals are perpendicular, that means that angle 1, where the diagonals cross, has to be 90 degrees. It's got to be a right angle. Then over an angle 2, well, if that's a right angle, then this is a right angle too. To get angle 2, we're going to make use of the triangles that are sketched out here. And know that we have a triangle where the measures have to add up to 180 degrees. That's true in any triangle, which means that if that angle is 90 and this angle is 35, that leaves the other angle in my triangle for the angles to add to 180, that the other angle has to be 55. So angle 2 has to be 55 degrees. Then for angle 3, to get angle 3, we're actually going to use hypotenuse leg here, which is that I have a right triangle here. I've got this side matching by the reflexive property, and then I have another pair of sides, which is the hypotenuse. So by hypotenuse leg, these triangles are congruent, which means that angle 3 should match with this angle over here and also be 35 degrees. So that's actually by catching some of the triangles that are happening within my kite and using that to get some of the angle measurements. Next one. We have a rhombus this time. So now we're going to refer to all the different things that are true about a rhombus. So first off, I want to know about D to F. And D to F, D across to F is a diagonal. Remember, diagonal goes from one corner to the other. And the diagonals in a rhombus, since it's a parallelogram, the diagonals are going to bisect each other. Which means that they're split in half. So I know that my pieces in this rhombus have to be the same. So if this piece is 5, the other piece also has to be 5, which makes the entire length from D to F 10. Then the problem asks us about DFE, angle DFE. Now, to get this measurement, we're going to use the fact, another fact about the diagonals in angle measures, which is that the diagonals in a rhombus are perpendicular. Again, you can go back to the chart and double check this. The diagonals in a rhombus are perpendicular, which means that this angle right here is 90 degrees. And then we have another triangle where the angles add to 180. This is 90. This angle is 62, which leaves the last angle in the triangle to be 28, so that the angles add to 180 degrees. Finally, we have D to G. And this is the easy one because D to G is a side. And in a rhombus, all the sides are congruent. All the sides are the same. That's what makes it a rhombus. That's what a rhombus is. So that means all the side lengths have to be the same. In this case, they're all 5.6. So that's my rhombus. For each one, we're looking at what things are true about the measurements that we're trying to find. And then we're using that to find those measurements. Next one, let's look at a rectangle. I'm going to go ahead and fix this real quick. So fix that in your notes. Make sure that that's correct. And we're going to start with M to P, the last one, because it's the hardest one. And then we'll do the easier ones rapid fire here. M to P. The reason this one's trickier is because it's a diagonal. And we know what this diagonal is because the diagonals bisect each other. So once again, if this is 5, this is 5, and the whole thing is 10. But the trick is that it's not asking for N to Q. It's asking for M to P. And to get M to P, we need to know about the other diagonal. But the good news here is that in a rectangle, the diagonals in a rectangle are congruent. They have to be the same. So if N to Q, one of the diagonals is 10, then the other diagonal also has to be 10. And now we have it much easier. Because to get N to M, that's a side in the rectangle, not a diagonal. That's a side. So we look at what we know about the sides in a rectangle. And I know in a rectangle that the opposite sides are congruent. So the sides across from each other have to be the same. So if I want to know what that side is, then I just need to look at the side across from it, which is P to Q. That's 4, so N to M also has to be 4. Then for the measure of angle MQP, well, good news. Angle MQP is an angle in the rectangle, and I know that all the angles are 90 degrees in a rectangle. So if I want to know what an angle in a rectangle is, it's 90. So notice how we're using 3 different things that are true about a rectangle to get 3 different measurements. And that's why it's going to be handy to have that big chart. So, last one here. This one requires a little bit of equation solving, but not much. On this one, we're solving for the variable. This time it doesn't tell us what the shape is. So look back at your definition, pause for a moment, and see if you can figure out what kind of shape it is. And hopefully you knew that it was a trapezoid because these sides were parallel and the other sides were not. But you should have also noticed that the trapezoid also had these sides here being 14. And since those sides there are 14, that made the trapezoid isosceles. Which is good news for us because we know something about an isosceles trapezoid, which are that these diagonals, which are the things we're trying to find and the things we're trying to find out about, those diagonals in an isosceles trapezoid are congruent, which gives me my equation. If the diagonals have to be congruent, then that means that these two things should be equal to each other. So that is my equation. Again, pause here for a moment and make sure that you can solve this equation. And hopefully you got C being 4. Which you can always plug in and check your work and make sure that your answer makes sense. In this case, that makes both the diagonals being 19. Which means that they're congruent, they're the same, which is what we were hoping would happen. So we're looking at what kind of shape do we have, and then we're going to use that to build the things that should be true about that shape.